Let's get going. Hi, I'm Tobias Artgrim, and I am going to give the talk about electromobility, the transformation with challenges. And so the idea of the talk will be a little bit that introduce myself, discuss this a little bit. I will create a user journey, and in this user journey, we will actually go through the process of charging. I heard already earlier when I was in here, there were discussions about the automotive aspects of the automotive industry and challenges in this. I will not touch too much the automotive industry. I will touch it because I am from this industry also, or in my past, but I want to make you aware of what is all incorporated, especially in charging an electric vehicle. So this is a little bit the talk. I think it's going to be about half an hour, maybe 35 minutes, my presentation. Then please feel free to also ask questions also after this. I mean, we have, I think, a 50-minute slot. So feel free then to have a discussion and ask your questions. I'm happy to answer whenever I can give you an answer. And a couple of things, it's going to be, it depends. Something I learned in my career. So very often the answer is always, it depends actually, because you can't have a definite answer. And as an engineer, you're like always like, you want to have everything exact, but it always depends a little bit on what is around you. So this is why probably some of my answers will exactly go in this direction. But I'm nevertheless happy that you're all here. Quick question, who of you is driving an electric vehicle or has ever driven an electric vehicle? We have two people here. So you have already had some experience in terms of charging it. Yeah. Okay, that's which electric vehicle?
Model Y.
Model Y. Okay.
And the Volvo Recharge.
Oh, nice. Okay. Yeah, so this is already great. I think we have two people here who have two different electric vehicles. You will directly experience a challenge because you have two different connectors. Mm-hmm. And how great would it be? You just go to a gas station and actually, like in a gas station, whatever car you have, you can just refill it. Electric vehicles are not there yet, but we come to this. Okay, so that's it. Off the flicker. Just see. My clicker. If the clicker doesn't work, then we do the it's just the wrong screen. Okay, so to me, born 1986 in Germany, so I'm German. Probably heard it already by the accent. Yes, there is an accent. I'm not from the US. So I was born in 1986. Now I'm 36 years old, turning 37, and I spent most of the time actually in the area of e-mobility and energy systems, my professional career. So I studied in Darmstadt, which is a big university for electrical engineering in Germany. Actually, the first faculty of electrical engineering in the world. So they're pretty proud of it. But I think it's always good to know. So I studied electrical engineering. Actually, my focus was renewable energies. So I was not focusing so much on electric vehicles at that time, more on renewable energies. And I wanted to see, you're like, if you're young, you're ideal, you're like, okay, how do you change the world? And renewable energies is a trending topic, especially in Germany. So I was really curious about it. And then came the time that I actually started going into the market. And it was 2014. I got my first job. And the offer was not in the renewable energy sector, it was in the electromobility sector. I actually started consulting for charging communication for electric vehicle, a big automotive company. And this is how I got introduced in all these challenges of e-mobility. It was right at the start. So the company I was working for was a very luxury brand in Germany. And they are usually one of the leaders, so they can afford, because the cars are really expensive, to just build a car and sell it for a lot of money, and people are buying it anyways. Yeah. So this was a very nice career step to have at the start. So 2017, I actually moved to Princeton. and I joined Siemens. I'm not familiar, if you are aware of Siemens, I know in America it's very often an unknown company, but it is actually a huge company. So I see some nodding. So yeah, okay. Big factory, big automation company. Yeah. So and in this company, I'm currently in the Princeton location here, and I'm a researcher. So and I focus on the energy grid and on e-mobility. And I'm trying to drive the topic of e-mobility here in the US also within the company. And then 2022, I got the opportunity to talk here at this event. A colleague asked me if I can give you a little talk about e-mobility. So I said, yeah. And this is why you actually see me here today. So in the process of this talk, I was like, what do you actually say? So I don't know, are you familiar with ChatGPT? Yeah, I was like, okay. I just gave actually my topic to ChatGPT. I was like, hey, ChatGPT, what are you saying? And ChatGPT was giving me actually always the same answer. And I was like, that's actually pretty much what I was thinking or talking about. So he was like, well, the challenges are the automotive sector, battery technology, the manufacturing processes, the vehicle design. In the infrastructure, charging infrastructure doesn't exist. We need to have smart grids. Costs are too high. The consumer awareness, people are not familiar with electromobility, it's something new. They're not knowing what are the benefits of an electric vehicle. They don't know it yet. Probably the benefit for them doesn't exist. And then the policy support is actually government. We don't have policies in place. And this is, you will not believe, but this is really, really big. Because you have to think about one topic. Okay. We come back to here, the Tesla and the Volvo car. You want to plug in your electric vehicle, you want to charge it at a public charger. That means you don't want to have a charger that supports every vehicle. It shall not be a charger where Volvo can charge or a charger where Tesla can charge. So it needs to work, because if you want to roll it out, you don't want to have 500 different chargers just to charge these different cars. So you have to standardize. It's difficult. Standardization across the complete industry takes years. So I was part of the committee in the ISO 15118, and the ISO 15118 is the communication protocol for charging electric vehicles. Probably what you hear is CCS, the combined charging standard. ISO 15118 is the origin of it. And how did it originate? It actually originated in Germany with Mercedes calling Siemens and calling Audi and saying, hey guys, it's great, this electric vehicle topic is currently pushed by the government, but we don't want to end up that we all have different interfaces towards this charge station. We need to have a standard for this before we actually can produce an electric vehicle. So we were all sitting together with the major German car companies, and you're aware we have a lot of car companies in Germany, so this is like the backbone of our industry. So there is a big push for this. We were sitting together and discussing how to do it. If you're familiar, there's also another country in the world that's also pushing for some of these aspects. You maybe heard of CHAdeMO. Do you know CHAdeMO? The CHAdeMO standard is also a standard for DC charging, for charging a vehicle, but it originated in Japan. We come to the interest game. Japan has an interest to push its own standard CHAdeMO. Germany was like, we don't like it. Okay, let's push our standard and make ISO 15118. Talk to the Americans. Americans were like, yeah, no, we're fine for this. Then we're like, oh, ISO standard. Takes 3 years to do. What can we do? We make a DIN standard, which is just a German national standard, which is actually the same as an ISO standard, just we can push it through as Germans within 1.5 years. And then we push everything this in the ISO standard. We go to the Japanese and say, hey, we are first. You're second, please follow us. Of course, it doesn't work this way. We have two standards. So we have in Japan, the CHAdeMO standard. We have in Europe and in North America, the ISO standard. But you see, this is like a little bit where this whole game is also. It's like companies trying to form alliances, countries forming alliances, other countries beating each other up. So China was looking at this whole thing and saying, you know what, guys? Everything great that you do, we do our own thing. And they did basically, and this is the funny part, they basically took the same concept of Shadimo and just turned two pins around. It's completely incompatible. Like you have to do everything your like if you want to sell a car in China, you have to do everything for the Chinese standard. And you're like, why? As an industry company, you're just like, why do you just turn these two pins around? It's like it's so easy, but at the same time, it's so much manufacturing process. And all of this that is behind it, where you're just complaining about it because you can't align your product. You suddenly can't have the same product sold in China as in Japan. You can't have this. And currently, these countries, you have to be aware, they are fighting for markets. So India, everybody goes at the moment to India and tells them, hey, use my standard. The Germans and Americans are coming and say, hey, we are the big ones, yeah, use our standard, it's so much better. Japan comes and say, hey, look, this is so much more reliable. China comes and says, hey, you want to have a trade agreement, you know? So this is like the constant game is ongoing. And just now what I want to go into this user journey that I'm going to present you for charging a vehicle. We will have a look at what is all behind it, how much things are involved in all of this. So this is you. This is you who bought the first electric vehicle. Maybe the second, it's okay. So you come and you have your electric vehicle and you want to go to a charge station and you want to charge. We already had the topic, connectivity. How do I actually plug things together? From my history, I can tell you there are other things that you would actually imagine they are like, you would not think about these failures if you haven't seen them, but they're totally clear. So I was involved in the first 800-volt charger. There was a prototype at the location I was working in Germany, and they had this 800-volt charger. So you have to know that with 800 volts, you go higher voltage, so you can have less current to transfer the same energy. So faster charging. So we had this charger, and my colleague called, and she's like, Toby, can you come downstairs and help me charge our vehicle? So we had a prototype that we wanted to charge. I was like, sure, what is the problem? She was like, well, can you lift the plug? And I was like, yeah, why? And then I went downstairs and I lifted the plug and I was like, holy shit. and she was a skinny girl. And she was like, I just can't lift it. I literally can't lift it. It's like lifting weights for her and putting it into the car. And because they put so much metal on the cable, and she couldn't lift it. You will now see very often that the cables are usually coming from the top. One of the main reasons is that it's heavy. You want to take weight off this cable. So, and these are things that you don't think about, but we are humans. We do mistakes. We don't think everything through from the beginning. We can't. It's too complex. So these are the things that we are not thinking about. We have to do the mistake. And if we do the mistake, we learn from it and we do it better the next time. But it takes time. And this is what we're seeing here, because it's a young industry. That's always something you have to think about in terms of challenges. Things are new. Industry is developing. Certain actors don't have experience of tens or hundreds of years. So this is something where you have to fail. And it's fine, you fail. We constantly fail. So here in our user journey, you are coming to charge station and you're like, okay, actually I just want to charge. So you plug in and you assume you get some energy. Well, pretty easy. Should be straightforward. You go actually to a gas station and gas should come out. Gas doesn't come out. Have to do something first. So it's not like this because did you pay? You have to pay first. But let's just stay quickly here. Energy comes up. Another nice story of what happened. So I was an engineer and I was at this company and we have test systems to test everything. So we have this new test system in a different country. They build it up. We tested before, we shipped everything over and they were like, it doesn't. And we were about like testing phase start. So in automotive, you have to be aware, like there's like always these deadlines. And a deadline is a deadline, and then testing starts. And then everybody complains and you never meet the next deadline. But it's okay, a deadline is a deadline because, I don't know, but it's very important. So so they were like, hey, this whole system doesn't work. Like we can't get it on. Like we plug in and it doesn't work. So we were like, okay, with this all this information, we don't know what to do. So it was Sunday night, like the boss called and was like, hey, we are assembling an engineering team. You all have to fly over. You have to make this thing has to start by Tuesday. So we are like Monday morning, all airplane, let's go to the other country. 5 engineers all sitting there, all like talking. Okay, we're going, seeing the test system. We're like, okay, what can we do? Okay, plugging in. We were sure. So we were looking around, and they were like, you know, this charge station. We opened it up. So the charge station consists of 2 things: the power unit and the communication unit. Power unit was wrong. But I was like, this other switch for the communication unit. Did you ever switch it on? And they're like, we never touched it. And I was like, everything is working. And it's like, so just 5 people sent across Europe to turn on the switch. So this is basically why you also, if you ever call somebody for support, you know what the first question is? Did you plug it in? Did you turn the switch on? Because this is actually what is usually the mistake. You will not believe it until you're actually in this position where you're like, I just flew here to turn the switch on, because human mistakes, they happen.
Was it somewhere nice at least?
It was not too bad. Beer is good, you know, so weather was not that great, but
And they owed you beer.
it's usually the good thing on these trips for with the company. All is included, and you have a good time if you have good colleagues. So there were things than these trips, but it's just to tell you like challenges. The challenges are just that people are not familiar with it. They're not familiar with the topic of how a charge station. Yeah. So we said that in automotive, like when we talk about automotive processes, the people in automotive are not familiar how to build an electric vehicle. Or now they are, but it took some time for another story when I was when we were doing crash tests in automotive. You have these batteries, they are 400 or 800 volt batteries in there. So you basically get a really strong electric push if you touch it, if you would touch the battery. So you do a crash test. Nobody's allowed to touch the vehicle till somebody declares that the vehicle is safe. This position did not exist in previous crash. This was a position that needed to be invented in the crash test. So they were doing crash tests, and then somebody was saying, guys, you're not allowed to touch it because somebody has to declare that this vehicle is safe, that the battery did not break, and therefore the whole frame is loaded with energy.
Well, to figure out if the vehicle is safe, don't you have to perhaps touch the vehicle?
Yeah, you test it. You just test if the battery is still working, yeah, or you measure the voltage of the frame. It's easy. You just say it did not exist. So and now you come to the idea of labor law. What would happen if somebody touches it and indeed dies? You know, so they had to stop the whole testing process and have to find a position, assign the role that he is the person who is just responsible for testing these things. And this just takes time. Again, it's something that people are, it is trivial, but you don't think about it if you don't think the whole problem through. And usually in management, if you come from the combustion engine side, you don't have people who are aware of these challenges. So you don't have an upper management who can scope with the problem. You have an upper management that can scope with different problems, but they are not aligned. So this young generation, all the people who are coming from universities, they are actually needed because they have a different mindset, but they're not yet in a position to drive these things through. And this is why it even takes more time. Yeah? So yeah, these are things that just happen. But back to our user journey. So no, we actually don't do this. We have to first give money to the gas station. So we can't really give money at the moment. If you had to look at charge stations, most of the charge stations, they don't have a credit card reader or so on. It was a big topic. So this doesn't work trivially. So there was also the idea, okay, you don't want to have this equipment with credit card reader and so on. So you have your app and or your RFID card. I took the app variant. You have an app, and then you connect with your app and send this to the mobility service provider. Here, this is a role that did not exist before. It's like something the mobility service provider. It's just there to provide in the end the service of charging. But you would say in a gas station, I just go there and pay. Important there to know, why does this exist? Germany was began in the role for this because in Germany we made a rule said unbundling 2002. And unbundling says something very simple. You cannot produce and sell energy at the same time. Either you're the producer or you're the seller. Because we had, in the end, 4 big companies owning the complete market in Germany. They were producing energy, they were selling energy, and the government was like, how can we break it? So we made unbundling. Well, we also wrote the standard, as you might remember, about the communication. So we said, well, there's somebody who sells this whole thing and somebody who produces the whole energy. That's why we have this separation. So you have a lot of things that we Germans invented, and we just push it out in the market, and everybody has to follow. It's really great to see that and to know the history behind it, because you're like, it doesn't always work like how Germany is supposed to work, but apparently a lot of people follow it. So anyway, so what you come to, okay, so you have a bank, and the bank also is not the best in terms of IT systems, I would say. I mean, we can see that. So it all goes over this mobility service provider to the bank. So now, okay, money is transferred. But now I have to tell the charge station that I'm allowed to charge. The bank will not do it. And the mobility service provider is not owning the charge station. So you need another person, charge point operator. And the charge point operator is just the person who operates the charge point. It's basically unbundling, provider of energy versus the reseller of energy. So there, it's like, if you think about it in the grid, you have the charge point operator is I think in the US it's combined, or if I see it correctly, in the US you have both roles still combined. So you would have the energy provider if you also buy from him the energy, or
Sometimes it depends by state.
okay. So this is so this is where actually the idea comes from. Okay, so the mobility service provider says yes, and the charge point operator says yes, and the charge station gives you energy. Not quite, because we have another topic, and this is also one of the challenges that you probably will see. Security. Is this whole topic secure? So now we have covered communication, we have covered banking. Now we're adding a little bit of security on top of it. So yeah, if it's secure, we can do it. There needs to be some security principles. And if anybody here did ever some product development and had to deal with security. This is usually in product development the last thing. And it's the first thing you should do. Because there are certain standards you have to obey. There are certain requirements that come towards your product in terms of how to establish secure communication. And if you talk to an engineer who's into building a charge station, he will be focused on how do I get energy from A to B? How do I allow the person to charge? But he will not think about how do I make this data transfer secure? You will very limitedly see these people that are thinking of it as a whole. So security is another topic, just makes it another challenge to look at. Okay, so we are secure. So now we get energy. Okay, so we have this, now we get energy. So, okay, this is where we say, okay, we have now here our power generation, our transmission. But there's something happening right now in the world. Transformation of the energy grid. So where do we actually get our energy from? Do we get it from the big power plant, from the nuclear power plant, from the coal power plant? Do we maybe get it from renewables? Do we maybe want to have a say? Do they have an interest in selling us energy? They have an interest. I think there was earlier there was a discussion in terms of here in this room. It was about the companies, the oil and gas companies, who are making bad advertisements for for inductive stoves. I think you were there. Yeah.
Yes, someone up there said that.
Yeah, exactly. So think about it. They have interest here on this side. Power generation units. They have interest in selling it. They have interest to drive their own transformation and satisfy their interest. But they're in this chain, and everybody who's in this chain has an interest. And everybody who's having an interest is trying to influence everybody else to work according to his interest. And this is what I want to show here is actually the complexity that we have a lot of people who have interests, and they're all influencing that. Some are in their own transformation cycle, some are new partners, but this is of course taking time. So this is where you see, like, for the e-mobility side, you have so many players who pull on you if you start being in this area. And then you have the government. The government is actually also looking at it because the government is what we earlier said, standardization. They also have to assure safety. And never forget, we all are the government because we are living here in a democracy. So we have the benefit of participation through government rules. So we form this. So and we have a demand that we request, for example, the demand of not getting an electric shock when we touch a vehicle. It sounds trivial, but I can tell you right now, we have a topic that we cannot do a software update remote on some of our charge stations because we cannot show to the extent that it's needed that we don't touch the safety functions. And we can actually show it, but the government is saying, well, we don't have a process for it yet to do a remote software update. So the idea of the remote software update is currently sending somebody there, standing next to it, saying, it is safe, do the software update, you do the software update, and the person goes away. He never touches anything, but he's just there to say it is safe. And of course, the interest is to be safe, so the interest is clear. The problem is the guidance does not exist, how to actually fulfill this interest. And then you come into the topic of opinions. Some people have this opinion, some people have this opinion. No guidance exists. What do you follow? So these are challenges that you will see because government guidance is needed and government guidance is missing. So, and this is where I will quickly stop a little bit and open it for some questions already because I want to have this picture up and see if you have. No. Oh. There are questions, so please,
I believe in this country, when it comes to electricity, most of it's generated through natural gas.
You have a lot of nuclear power. That's not.
Maybe in New Jersey, but the rest of the country,
Cold still.
We haven't built, we haven't,
natural gas pretty much.
we haven't built a nuclear plant in this country in almost 30 years, over 30 years.
We don't build them, but we still operate now. They're running. So, but this is a question where this is a huge topic actually that impacts electromobility, the transformation of the grid, because how the grid is currently formed, it will not sustain everybody having electric vehicles. It's just too much electric vehicles, too much demand on the grid. So you have to think about solutions.
There's been discussions about moving the grid closer to the point of use.
Yeah,
I know Elon Musk proposed when they were rebuilding Puerto Rico, he proposed going in and building a whole new smart grid and a whole new grid where the power generation is closer to the user.
Yeah, and this is where you usually see the topic of renewables evolving around. Because renewables, so the traditional grid is situated from the high power part to the distribution, so from the transmission side to the distribution side. Transmission side is what we actually see. If we hear that we have a big power generator somewhere, for example, a nuclear power plant or some coal power plants, they're sitting somewhere, you have the transmission lines and they bring the energy out. And in the distribution network, you just distribute it, just locally distribute. But with renewables, we actually see more and more production in the distribution line, on the distribution side. So further down, you would say, from the energy perspective. And this is a change. And this is the change you have to scope with. Again, there's also a question how to scope with. Not all the technologies are ready yet. So I remember a colleague of mine, they were proven in Galapagos 3 years ago that a smart grid can be operated just on inverters. Sounds trivial, but it was a real challenge. Usually what you have in a grid, you have rotating energy. So all the big power plants, they have rotating energy because they actually run a turbine and then rotates. And to do control, you have like the inertia automatically exercising control. If you have inverters, you don't have this inertia anymore. So you have to be fast enough. You have to, your inverters have to control the grid. Your inverters have to monitor the grid and do this on scale. So this is like you have in Galapagos, you have a smart grid operating. So you have on several islands, you have this now, like these concepts, but having this on, I think Hawaii is currently in the US working towards this. But Hawaii is not mainland. It's just bigger. So challenges. And this has nothing to do with electromobility at first. It's just the sign up right there. That's really.
So some of the problems you're talking about with the grid seem like big sort of long-term things to get worked out. I'm curious about how the sort of we get standards applied for just like charging stations in the cars and things like that. Usually it's either market forces steer things one way or the other, or maybe the government takes a hand in it. How does this all kind of come together and just have islands of different kind of charging connections based on what?
But I think it will come down to that you have one connector for like now for charging station, for the connector charging station to vehicle, you will have a standardized interface and you will obey all the same rules, because I think there will be a push from automotive. They would have, if you have multiple, let's say within the US, you would have to support multiple sockets on the same vehicle. This is actually the reason for what you are aware of, the CCS standard. So the combined charging standard, the reason for, if you look at it, is that you have AC and DC charging combined in one plug. And the only reason for this was that the car companies were saying, we don't want to have two sockets here. We just don't want it. It's a horrible thing. And for car companies, there's one discussion that is very, very big in car companies. And it's the packaging discussion. You're aware of the packaging discussion? Packaging is how much space does some unit in the car get? How much do you need? How much space do you need? And if you can save 5% of space, you say, hey, we have this great invention. We form our complete thing a little bit more compact. And you save 5%, you're the hero. And if you need 5% more, well, you're not the hero, you're more the one with an A starting, and that's a word that I would not use. So this is like these discussions are usually happening if you start the construction of a new vehicle. It's always a question, okay, how big is the package that you need? And if you can shape this down, you get money in this industry. They're like, hey, we push for it because we want to bring this down.
Because less space for something else, needs more space for a battery, right?
more space for battery, less weight, probably, and then other comfort function that you can bring in. You can maybe bring in a lower class vehicle, a higher class comfort function, which gives you opportunity against your competitor. Weight again, and also you can build your car maybe more compact. So there are lots of things that you like. That's all in this packaging discussion. Packaging discussions are really like a big thing in automotive. So and you would not think about it because you're like it's just a little bit, but it's like no. And also if you see it, so when I was at automotive, it was like so they draw a graph how the weight actually developed in cars. And if you see it, currently the weight always goes constantly up. But all the old functions, what you have, what you call vehicle in the past, goes down. What brings this up is a lot of times cabling. Cabling is a huge thing right now. They're looking into how can they replace cables because so much weight, and less weight means less consumption, maybe better handling, more flexibility in distribution of the weight.
I'm sorry, are you referring to like the number of cables themselves or the materials that the cables are made of?
The number of cables. Like you have more cables, and this cable tree is just now it has a tremendous weight. So yeah, this is these are challenges in the automotive. So now we're back to the automotive industry, sorry, because I come from there. But what I want to highlight is a lot the charge station and what is all behind it. And if we think about it towards the future, I mean, here you're still plugging in and you're plugging out, but we think it one step further. We don't want to plug in and plug. That's something that the car can do itself, or I mean, wireless charging, yeah, automated connecting devices. Things are set up for it, and it probably looks like this. So if we automatically do the connection, how do I pay? The car has to pay. The standard exists. It's actually a function that you will hear. It's called plug and charge. It's a function where the car is showing its certificate and saying, with this certificate, you are allowed to, you can authenticate yourself and then you can charge automatically. Yeah, and everything get built in the background. I'm just saying this is, it sounds trivial, but it adds another layer of complexity because you now have this information flow to the mobility service provider that you see at the bottom now. Somehow over the chatbot operator, you need more government, and we didn't even touch topics like service and logistics that are involved in all of this. So there are a lot of areas that are involved, and this is like where my company in the end sees it. I would say e-mobility. If you go between automation and digitization and electrification, where you see all these different challenges, e-mobility is right at the center of it. Yeah, you combine all of these challenges together, and that's where you are. Actually, there is on the bottom, you also have the smart grid. So these are from the infrastructure. It's just so many things where you try to increase efficiency. You have the decentralization where you have to think about how do I actually take a car and take cars on scale and include them into the grid. How do I load manage this whole system? All of these is like huge questions. Yeah, please.
So a lot of discussion around range. So, and range is one of the things that comes into the charge points, right? But which one of these variables would increase range? Like, are you looking at the efficiency or the actual charge, the batteries?
All of them. Range is range is like a subtopic in automotive. Like you go into the topic of battery technology. I think if you look at just the range topic and the battery technology topic right now, you observe a couple of things. At first, it's the car companies, the new cars are not hunting so much range anymore. You come to a range size where a lot of people are okay with it. And how can you tell that? usually they were always using the top-notch batteries, the top-notch lithium batteries. Tesla, I think, already changed the newer models to the lithium iron batteries,
Yes, lithium ion, yep.
which is not top-notch anymore. It's one step lower in terms of energy, but has a lot of benefits in terms of handling, in terms of safety, in terms of lifetime. You also have rumors about natrium batteries. I think this year the first natrium battery car in China was launched. So they are like, China is really big. It's like basically China is pushing technology all in, and I think US and Europe is a little bit behind on a lot of these topics. So, but you see that there is a small downgrade in terms of technology. So you have, and why would you downgrade? You just downgrade the technology. It provides you other benefits than range. So optimization in range is probably not first concern anymore because you have achieved a certain range that you want to achieve. And I think with a Tesla, so if you drive a Tesla, it's pretty convenient, or from the range perspective.
Yes,
Yeah,
so the EPA rating for a long range Model Y, for example, is 300, but realistically with climate also, turned on, stuff like that, you're getting 250. But if you're driving very fast or the weather is very, very cold or a lot of rain or wind, maybe 200 miles. So 200 miles worst, probably 250 or 260 miles at best.
Yeah, but this is, I think you're in this range, like, so European, I think kilometers, it's like when you say miles, I always have to say times 1.6, okay, this is where we go. But so about 400 kilometers, I think that's also the range that you see where most of the people take a break. Most of the people go for a coffee, go to pee, yeah, and they can, if there's a charge station, they can charge. So this is where you have these high performance chargers. They are like all charging the car within 20 minutes or so on. So, and this is one aspect of chargers. There are different aspects of chargers. We have the high performance chargers which are fast charging. There's a Tesla network which is very famous. The other chargers are, for example, AC chargers that are like used at home. Different, and there you have just different ideas. In my company, we have deployed on our location everywhere AC chargers. It's actually super convenient. A lot of my colleagues who have an electric vehicle, they just come and charge at the company. They have always a charge vehicle. It's also not a problem to just have a car that has minor range. If your company is offering you charging at your company, you can always drive to your company, drive home, charge also a little bit, because actually utilization of a car, I mean, it's not very high. And that's what people should also realize, that it's a very luxury good.
One thing that came out, my friend was showing me the other day, he has Tesla and he used summons, so it came to get him at the front door. The annoying thing is that the chargers at the mall are all the way across the parking lot. And you can't summon the car when it's on charge.
Yeah, but this
So
would
it'd be nice if the car could somehow unplug itself and then come to you.
Yeah, and this is the automatic connecting device on the one hand side, and also the other thing that we talked about, human mistakes, we learn from it. We do it better the next time. Maybe there was an idea why it's there, and maybe it just didn't work out. And they're like, oh, maybe it's smarter to have these chargers somewhere else.
The batteries have gotten cheaper though, correct? Like when you think about per kilowatt hour, how much you have to pay.
Yeah, exactly. Batteries are getting. I think this year was last year was the first time they got more expensive. They have a small bump up, and that was mainly due to the high demand, and also I think there are a lot of discussions in terms of who has the rights and so on to actually grab more lithium out of the earth. So, but expectations, it's going down. So the price for battery the expectation it's going down.
Remember a decade ago, it's way lower, right?
Yeah. So actually we are already in the middle of the session of the questions and discussions. And yeah, so what I wanted to bring to you today is just the awareness of what are all the topics that are standing behind charging an electric vehicle. It's always not that trivial. A lot of things, a lot of mistakes are going to happen and will happen. And you can expect them to happen. So don't expect everything to work from the first time because it never does. So you will, yeah, just to make you a little bit aware, probably give you a little bit of curiosity because there are topics that you maybe are not aware of, you haven't heard for so far and want to be interested in and so on. So there are things just, yeah, to maybe take away, and this is yeah, what I hope for, and also to give you the opportunity to tell you a couple of these challenges and yeah, just introduce you to the topic if you're new to it, or give you the opportunity to also ask me now questions. If there anything else you want to